Hello to everybody over the ocean from Karlsruhe in Germany. And I'm happy to present, what's new in PTV Visum 2021 to you, which has just been released in the beginning of October. So it's already available to all of you. So let's start by something we are very happy that came even up to Brittany's mind, actually. Yes, we did it again. We worked on speed and performance of the software. So as you may be aware, we have been working on that over the years, all the times, mostly in certain areas such as the assignments, highway assignment, and the public transit assignment, for instance. So you get an overall improvement throughout the years. And this year we achieved something which is very nice, because we were able to do some tweaks to the general memory management of the software, which helps to improve many different procedures. As you can see, for instance, in the assignments, specific assignments like the Frank Wolf assignment got up to almost 50% of improvement, but also things like matrix estimation and filters and so on. So big improvements almost everywhere. And we also worked on the file format of the software. So even the version files get much smaller than they used to be. So very nice, and I think very helpful to each and everybody. Okay, so let's have a look into the more functional parts. I will start with showing what's happened with respect to the procedures. And I'll start with something in the area of public transport, where we introduced capacity restrictions in public transport, which are, for instance, very helpful right at the moment when you want to model the effects of social distancing. Actually, capacity restrictions could be modeled within the public transport assignments even before. So it was already possible to reflect something like the discomfort by crowded vehicles and the impedance, the effects on that on the route choice of passengers. But now we introduced a real failed to board procedure. So you get the direct influence of crowded vehicles, a hard constraint, so that really only as many people as there's capacity can board a vehicle, and other people might have to switch to other connections, or might even need to wait for some time. So how does that work? Imagine a situation where you have several connections, like the yellow ones here, with a capacity of 100 seats, an alternative connection for some stretch of the connection with a capacity of 50 seats, and maybe a line coming in at that node here. Then you see that already there are some passengers on that yellow line, like 80 passengers in that example here, and maybe like 30 passengers coming in from another line, which would need to transfer at that point, like 30 passengers, and maybe another 10 passengers wanting to board at that spot. And you can assess there's 80, there's 30, there's 10, so that would be in excess of the actual capacity of 100 passengers being available on that stretch here. And what happens then is that for the incoming journey items or passengers, the capacity or the numbers of passengers who can board this vehicle journey here is reduced for all incoming connections at the same share, so all are affected equally. And for those who can't share, alternative connections are searched beginning 1 second after this original one would have been here, and then they are assigned to these alternative connections, and in a way that makes sure that really capacity is never over-assessed. Okay, in the results, of course, what you get is connections which are never in excess of the capacity, and you get quite a lot of additional information or additional outputs So for each connection, you will get an indication of how many people were not able to board it, which could not be made. The number of passengers who failed to board, a notion of the risk of failing to board. So this is also related to the delay which the passengers assess. And for instance, also for the stations, you will get an indication on how many passengers failed to board there, which can give an indication on about crowding at the stations where maybe also station capacity may be accessed. And you get the same information also in the skim matrices between zones. So the risk of fail to board or the number of passengers who fail to board in the connections there. Okay, from public transport, we move on to ride sharing. You may know that ride sharing in PTV Visum can be modeled in two different ways. So it can, on the one hand, be modeled as a separate mode. And in that area, we added the option to assess how a ride sharing system works when electric vehicles are used, and also when holding areas are modeled. Sorry, that's missing on the slide. And the second way to model ride sharing is in conjunction with the public transport assignment. So we call that the intermodal assignment, where passenger journeys can be either or can be combined by public transport and ride sharing. So as I said, when you are modeling ride sharing as a separate mode, we added some options to this. So now it's able to model electric vehicles with consideration of the ranges and also an assessment of the or an approximation of the duration of charging. And for the holding areas, this allows you to improve the routing by sending the ride-sharing vehicles back to certain areas where they wait for their next trips to be assigned to them. So you see, for charging, it's really just an approximation. It's not a real simulation of that, but the typical vehicle range can be included, and a certain notion of the charging time. And then within the ride-sharing simulation, when the battery state gets low, vehicles are sent back to the charging locations and are not accepting new trips for a certain time, which is needed to recharge them. Yeah, and the holding areas, as I said, it's a bit similar. So the holding areas are spots where the ride-sharing vehicles can be parked in between the trips. And so when they don't have a trip assigned, they will return to the closest holding area, which is also useful, for instance, when you want to model that vehicles are relocated to spots where the next demand is expected. So when you are forecasting demand for ride sharing, then the vehicles can be assigned closer to the upcoming demand, and thereby by the general routing and the assessment of the fleet needs is better done. Okay, then in the intermodal assignment, so the combination of public transit and ride sharing, we have done some improvements. That was included in the software already in the last release in Visum 2020. And we flagged it a little bit as experimental because it was really not that mature at that time. So we improved that to a certain degree. We improved the convergence of the procedure and also made it run faster. So the basic improvements are to the general workflow. You see this intermodal assignment is really a combination of a macroscopic public transit assignment and a microscopic simulation of the ride-sharing part, of ride-sharing stretches or parts. So where really individual trips are generated, and for them a tour planning like in the standalone ride-sharing is done. And then the results from this are aggregated back to connections between the zones. And what was added now is the possibility to provide initial values for the route searching procedures for that. So an approximation, for instance, about the travel times with the ride-sharing system on the level of main zone connections. And by providing better initial values, the initial phases of the simulation can be sped up significantly, and thereby the whole process can be sped up significantly. So it's now possible to provide a matrix as a start for starting values here. This also allows you to even leave out the entire microscopic process and still have a notion of the ride sharing within the public transit assignment. So for instance, when you're really in strategic demand modeling, you can simply assume that in your area there is a certain ride sharing system with a given or an assumed service quality. And then you can just provide a matrix of this and really leave out the whole microscopic simulation process, speeding up the whole simulation or the whole public intermodal assignment a lot. And of course, as you can input those values on the main zone level, you will also get results on that level. And this is really helpful for analyzing the results as you get high-level outputs on the quality of the ride or on travel times and other KPIs of the ride-sharing system, which lets you really analyze what's going on. Okay. I move on to general demand modeling. So with Visum 2021, we provide a small tool which allows you or supports you with the calibration of demand models by doing a little bit of an auto calibration of the demand model. So imagine a demand model which produces demand matrices for a number of different modes. And what you usually want to do with such a demand model is when it produces, the model produces a certain mode split for the different modes. You want that this mode split is more or less equal to the mode split you get from surveys, so from the real world data. And of course, this is very often quite a time-consuming process in demand modeling to set up the model and then to calibrate it to match the survey values, mostly with respect to mode choice. And therefore, we provide a new tool which allows you to calibrate or to auto-calibrate the modal split and also the average trip distance for different levels. So, for instance, for person groups, so for the whole model, but you can even also restrict it to certain OD relations. So sometimes you only have the survey mode split, for instance, just for the work trips or for certain parts of your demand and not for the entire network. Or you want to calibrate for different values of them if you have the data for different person groups, for instance, separately. So how does that work? It's provided as a set of add-ins. So first, there's a small add-in for preparing your model, and that will do a few things. It will complement the utility definition you're using in your demand model by certain additional terms, exactly by the calibration terms, of course. It will add some user-defined attributes to some network objects, which you will then use to provide the served values, the target values. And it will add or it will modify the procedure workflow. So it will add a few procedures which form a loop around certain procedures in order to do the calibration actually. So to assess the values and then to modify the utility definitions by changing the coefficients of the correction terms so that at the end your target values are matched. Okay, The second step is then actually to provide the target values, so to fill in values for the user-defined attributes generated by the small preparation add-in. And finally, then execute the procedure sequence, and you see this will then have a few more loops, so it might take a little bit longer, of course, because yeah, the calibration simply takes a few steps, a few iterations in order to reach the values. Okay. So that's yeah, it for the procedures, and we move on to a few visualization tools which are new in Visum, namely two. The first thing, or the first tool, it's a new visualization of individual vehicles coming from the simulation-based assignment, so from the mesoscopic or from the dynamic traffic assignment procedure available in Visum since a few years. So this is getting, at least from the visualization, even a little bit more microscopic, and let's really see you individual vehicles in Visum. I think I will show that to you in the software directly. I hope you can see my screen.
Yes.
If you can't see my screen, then Bill, give me a note. Okay, that's fine. I here have a network prepared for this, and within the network I have an assignment procedure for the simulation-based assignment. And this got a new parameter or a set for the visualization, which lets you control how during the assignment procedures data about the approximate trajectories of the vehicles is generated and stored. So this is done during the assignment, so you have to prepare your assignment a little bit in order to produce the vehicle trajectories, which can then be used in the visualization. Okay, and by those parameters, for instance, by the temporal resolution, you can control how big the data gets at the end, so how detailed you want to look into this. And as you can see, you can also restrict that, for instance, to the active links or to a certain time period. So when you just want to look into certain parts of the network, then you can keep the result data much smaller by restricting the outputs to some degree. Okay, once you have done such an assignment and prepared this visualization data, then there's a new type of view in the 3D network window. So we included that there. It's not in the normal network editor, but it's in this 3D network view. And if you set it up, then you can start an animation and see the vehicles moving around. As you might see at the moment, that's quite slow, but because it's running in original time, but you can also speed that up and see the moving dots. So it's not really vehicle models as you would have in Visum, but it's really only dots or boxes of the vehicles. So now I can also move in here, as you can see. And this network view or this animation view can be controlled through some graphic parameters. It's also interactive, so when you click on the intersections, you can see that it's linked to the other windows, and you will get more data on the sections or more perspectives on the sections where you click in the network. Okay, this is already quite nice. But it goes even further because it's included in the 3D network view of Visum. You can also use the other features available there. So for instance, you can set up a storyboard. I've done that already in this example, which lets you produce a nice video animation flying through the network as you are used to it maybe from Visum. So I start playing this perspective here. And you see this goes on going through or looping through predefined camera positions and transitioning between them, zooming in on certain intersections. can also switch between different graphics parameters. And here you see that, for instance, also the vehicles can be colored. Here it's colored by the speed. So the blue vehicles are moving at desired speed. The pink ones are stopping, so the speed is low. And you can also see, it's maybe a bit coarse here, that it's also possible to color code the signal controls by the current signal stage. Okay, so yeah, as you've noted, this is not as elaborate as maybe in Visum, where you have the fancy 3D models of cars and the buildings. But still, this animated presentation is really, yeah, for instance, on the one hand, really giving a nice graphics, but we consider it very helpful, mostly for the model calibration. So for figuring out where are issues in the model, where do vehicles get stuck, where they shouldn't, and so on. That's the main purpose of that integrated tool in Visum. Okay, I go on with the second new visualization tool that's more related to demand modeling and general modeling. We call it activity profiles. So it's a new view in Visum which lets you analyze data which changes over time. There's a set of different applications for that. The most obvious one is for activity-based models, which have been included in Visum in the last version, in Visum 2020, where we have provided a whole data model for input and output data of activity-based models. The same tool can also be applied to other areas, for instance, for ride-sharing evaluations, for the vehicle scheduling in public transit vehicles, and also for the general public transport services. I will also show that to you in the software using an example from the area of ABM. So you see here this activity profile on the right side, and this has, besides some parameters, two parts. In the top part, you get the temporal distribution of different types of activities. In the ABM example, this is, for instance, the activities of the different agents, like working activities, shopping, education, and so on. So you get the number of agents doing a certain activity over the time. And in the lower part of this view, you actually you can select a point in time in the top window, and then in the lower part of that window you will see the actual individual activities which make up this part of the diagram here. At the moment, the window is displaying the aggregated data for all activities in that model at a certain time. But you can drill down on individual objects here and assess the data or evaluate the data, for instance, for certain activity locations. I will do that now. So, of course, this is also linked to the network window. So when I here click on a certain activity location, then you will get the distribution of the activities happening at that location over time. And if I click in the window here, then I get the individual activities making up that distribution at a certain time at that object. And even down here, I can click on one of these activities. And if you see the quick view window, then you get the attributes, so the detailed data of that specific activity execution at that location in that moment of time. And you can simply click on the different locations here in that window and see how that affects. You see a little bit, this is the effect of the example I'm using. that at each of these activity locations, you only get one type of activity. So I changed the type of reference objects a little bit. So I now look into the zones. Okay, and for the zones, the data of all the activity locations associated with the zone are now aggregated. And I see, for instance, here over the day, how the different activities separate. And if I click down here, I can analyze how which individual activity executions make up that distribution over here. So yeah, a tool allowing you to drill down in time and space in the dynamic data produced by the ABM model. And as I mentioned, the same tool can also be applied, for instance, to public transport journeys, to the schedules of public transport vehicles, or to the trips and tours of ride-sharing vehicles, for instance, where you can evaluate how many people are sharing a vehicle at a certain time and how many vehicles are used at a certain time. Okay. Then I go on with a selection of a few smaller features. So we did an improvement of the scenario management, in particular for public transport. So when you're analyzing scenarios for public transport, imagine a base case where you have a certain line running here from zone 1 to zone 2 through the center here. And now construction is scheduled to go on. And for this construction, you will need to implement certain detours. So maybe in one phase of the construction, you need to run a detour through this node 12 here. And in another phase of the construction, you need to run a detour following that path here. And those could be modeled as two separate modifications in the typical Visum scenario management. But it might be that now you also want to consider scenarios where those two modifications are combined into one, or into one scenario. So for a certain period of the construction, for instance, you might need to run both detours or reroutings at the same time. And in the past, this would have been really difficult when those two detours were modeled as separate modifications which affect the same public transit line. You would not have been able to combine those two into one scenarios because yeah, either the one or the other would have won, but you would never have seen the combined effect of both. This is now possible. So yeah, it's now possible to really combine modifications for public transport which affect different parts of the same line route. Of course, if they are overlapping in some stretch of the line route, then you will still have difficulties in modeling that, and that will not work. But at least when they are not really in conflict to each other, then you can combine them in combined scenarios. Okay. Another item added in Visum 2021 is what's called user-defined tables. So as you know, you have always been able to extend the Visum data model by user-defined attributes for any data type. And you could also model any additional data as points of interest already. But those points of interest were always a bit difficult because they have a certain geography or geographic objects associated with them and so on. So far, it was not able to simply add a plain table like an Excel table or a database table to the Visum data model. This is now possible, so you can model tables which just provide some data without any geographic objects associated with them. Of course, you can add any number of attributes to them, also formula attributes, and you can use functions in the Visum dataset like the table lookup and so on in order to access the data provided in those tables. And this is, of course, helpful when you want to provide additional input data for models, for ABM models or other types of parameters. Maybe if you want to produce statistics through add-ins or through scripts, you can populate now user-defined tables and many other things. So we guess there will be plenty of applications of those tables so far in the future. Sorry. Okay, something which could be in the procedures part actually, but not so much. We did some improvements to the emissions modeling. Sadly, this is still not really that well suited for the American market. It's more suited for the European market because along with Visum, we provide a set of emission factors which are coming from a database which is only available for some European countries. But still, I want you to make aware of that because maybe you can adapt some part of that. So even already in the last version, we have updated this database of emission factors and also fleets, vehicle fleets to the latest state. And in Visum 2021, we have done a few improvements to the whole deployment and to the user interface. So it's now a bit easier to install this database, which is quite extensive. It's a few gigabytes of additional data. And there's now also a number of lists where you can compose or where you can modify the fleet compositions and define what fleet to be considered in when modeling emissions. And thereby you might even be able to apply it to the US situation possibly. Okay. Moving on, we've worked on or redesigned a dialogue which is used frequently by many people, but which has not been touched by the developers for, I don't know, almost a decade or so. So it was really ugly and difficult to use. This is the dialogue for saving networks or parts of the network, and also for saving demand data and some other things. So this dialog has been completely redesigned, and it's now much more easy to select which tables you want to export or which you want to exclude and which attributes. It now allows multi-selection, which was not possible before. And it's much more convenient to use than it was in the past. Okay, to move on, we've done a few things to the import procedures for public transport data mostly. We have updated a few importers for public transport data, I fear, which are not that relevant to the American market. So the GTFS importer has not really been touched. But I think that's working fine already. But what we have worked on is a few tools which can be used on any type of public transport data which has been imported into Visum by any importer. So there's a new tool for simplifying networks which come from those importers, where you often get, for instance, parallel public transport lines for each service which is in the data. Or other types which are artifacts of the actual imports. We have worked on tools for aggregating vehicle journeys. So again, when from the public transport data, you get many parallel vehicle journeys because that's how they are coded in those import data sets. It's now possible to better aggregate them into data sets. And also some further things for working with the temporal data, so to determine when actual services are running and when not, to link that to the calendar in your data model. Okay. Besides those software improvements, we have worked a lot on the examples provided with the software. So for much of the functionality introduced in this release and also in the past release, we have updated the examples or provided new examples. So for instance, you will find an example for an activity-based demand model implemented in Visum. This uses a set of Python scripts for the actual modeling, but makes you aware on how to use the data model introduced in Visum 2020, so the input data and also the output data. There's an example on how you can use Visum to model autonomous fleet vehicles in a macroscopic model. And of course, also an example for modeling Ridesharing, which has been adapted to the new tools I described in the beginning. Okay, in this presentation, I focused a bit on the bigger features introduced with Visum. As you are used to, this is really only a small selection. There's a lot more things in this release. And I would just point you to the release notes, which are always updated with each service pack and show you what's new in that software. And of course, also to the new features document, which gives a bit more information on the highlight features of this release. Okay, and with that, I would already close or finish the presentation, and I'm looking forward to answer your questions.
Excellent. Thank you, Arnd, for that great presentation and tour of all the new features. We definitely appreciate that. I'll start with the first question for you, which is, can you explain any similarities between the auto calibration and T-flow fuzzy?
Okay, those are really two different or two separate things, because the auto calibration will work on the actual demand model. So when you have a demand model procedure in Visum, actually, I forgot to mention, it's at the moment only working with quite simple 4-step demand models and also relies on logit choice procedures implemented in them. So when you have such a model, this auto calibration add-in, it will add additional terms to the utility functions, for instance, for the different modes in this demand model, and then modify the procedure sequence for some additional steps which estimate the values for those terms added to the model. And then the model will run as it does before, or as it would do without that, but just do a few more iterations, and at the end produce matrices. But after this procedure has then run, you can examine how those correction terms have been modified by the procedures and see what what coefficients have been set in order to match the target values. So this will really influence the full demand model procedure and try to calibrate that. Whereas the T-flow fuzzy is simply a matrix correction procedure, which you can even run without having a demand model at all. So this is really based on having a modeled demand matrix, or it can also be a demand matrix which has been generated externally, not even by Visum, and some counts for different types of objects, like link counts for cars, or it can also be passenger counts on public transport lines. And then T-flow fuzzy will just adjust the matrix values in the demand matrix so that a following assignment would better match those count values. So this works only on the matrix level without really requiring to have a demand model and without taking care for the demand model at all. That's the major difference between those. And they are also working a little bit on different types of counts or different types of survey data. As I mentioned, the T-flow fuzzy, so the matrix correction procedure, is usually applied for when you have counts, vehicle counts for links or passenger counts, so on counts data for objects, whereas the demand model calibration, this auto calibration tool, is more used for accessing or matching target values such as a global modal split, for instance, which is not on the network object level, but more on the general model level.
Okay, excellent. Thank you for that thorough answer, Arnd. Appreciate that. Next question for you. Let's see. Says last year we heard about a procedure for modeling AVs, which was quite convoluted using custom VDFs. Have you considered setting PCU values by transport system by link type? This would simplify the AV modeling as well as make it easier to model trucks with different grades by choosing a different link type.
I'm pretty sure we have not worked or not further worked on that. So yeah, I will feed that into our wish list and our requirements loop. So that's interesting, and yeah, we will consider that. So okay. Yeah, we have not really worked on that with this release. It's in the same state as in Visum 2020. Okay.
Next question is it possible to record the SBA visualization?
Yeah, that's as it's part of the 3D network window where you can set up this the storyboard and use the recording functionality as with other 3D animations or visualizations as well.
Okay, great. You know, since we're not doing an actual hot seat today on Visum, maybe I can grill you on, maybe you could just share some things that we all might be able to look forward to in the future, some things that you guys are working on there that you might want to give us a little heads up on. If you can think of anything that you want to share at this time. If not, we do have another specific question here I'll read to you as well and let you pick, Arnd, on what you want to say at this point. Question is, can you expand on any examples or features to the least square ODME?
I would not really be able to expand on this. We have also worked on the example for matrix estimation. So this has been extended for the new ODME procedure, as far as I know. So it might be worth to have another look on that example. But apart from that, yeah, I can't just elaborate further. Maybe if you have specific questions, then you can channel them through me and I will forward them to our experts. But that's all I can do at the moment.
Yeah, and that's a good reminder, Arnd. Anybody who asks a question that we don't fully answer during the session, by the end of all of the UGM sessions, we'll be compiling answers and getting those back out to you all. All right, our next question came in. Any planned improvements to the network editor specifically for SBA purposes? A network editor view like Vistro would make it easier to edit intersections.
Actually, that's something which we are currently discussing for the next release. So yeah, you can already look forward to that one. I can't promise too much because we are at the moment a little bit brainstorming on what to do in that direction. But improving the junction modeling and general network view for the more traffic engineering related features, that's surely on our wish list or feature list for the next release.
Great. Any news that you can share on anything related to the emission modeling for U.S. applications? Any progress or discussions?
Really not so much. No, we have at the moment no plans, or we have not developed plans to provide a more direct integration of that. It might be something to consider. So if that topic is becoming more important to your market, which I assume it will possibly in the upcoming years, then that's really something we could look into, or we would look into. At the moment, no concrete plans.
I have a feeling we'll be concerned about the environment again here in the U.S.
Yeah.
In a couple of months. All right, an example of modeling park and ride in the context of Visum tour-based would be helpful. We have it for 4-step, but not for the tour-based. That's anything you'd like to. Well, please note that, I guess, and anything you want to add.
I would also just take that for the wish list. So it's interesting to hear that you're looking into Visum, into the tour-based modeling. So great. And of course, with park and ride, it's interesting in that we will see how we can provide or set up an example, including that as well.
Okay. Great. All right, well, that's for right now, but the questions have been streaming in as we've been talking. We have a couple more minutes here. I won't artificially prolong us since we don't have any official coffee breaks or anything, but I'll just wait a few more seconds in case another one comes in. Otherwise, Arnd, thank you very much. It's exciting to see all the new developments. Excellent presentation as usual.